Hi everyone, in this video I'm going to work through a question that I had to tackle during a job interview for a tutoring role where I actually completely bombed out of the question. In the moment of the interview I couldn't actually work it out, and it wasn't until the person interviewing me was able to kind of give me a bit of guidance and kind of prod me in the right direction that I could actually get to the answer. But I thought I'd work through it because it's actually an example of a great question, quite an elegant question in that it's fairly simple, yet really, potentially quite tricky. So as background, I mean, soon after I decided that I was going to pursue the path of becoming a high school math teacher, I figured I needed to find ways to kind of revisit all the math that I'd forgotten over a few decades, and that's partly why I started Tick Boom. I mean, it's to help other students, obviously, with their math, but it's also to help me relearn all that math that I'd forgotten. So basically, I saw this job for a tutoring position on my university notice board, so I thought I'd apply, and I found myself at an interview with the person who created the coaching college. I kind of made it clear to him that I was a little rusty. I think if you look at my transcript and my history, I think it's quite clear that I can do math, or at least once upon a time I could do all this math, but I didn't hide the fact that I was a bit rusty, and so some of it was a bit of a distant memory. So after the initial kind of discussion part of the interview, I was then given this question, and the person interviewing me, basically the instruction was that this is for a Year 8 student. I think Year 8, it might have been Year 7, but basically early high school, and they have just learned Pythagoras Theorem. And basically this is a question, I think it was taken from an exam. I think it was a Sydney Grammar exam. Yeah, Year 7 or 8, I'm not sure. But basically I was told to assume that the student could make use of Pythagoras' theorem, but nothing else. So no other trigonometry or circular geometry results could be relied on. Basically, find a way to, in this case, it's find the radius of this circle in terms of h, where h is the height and width of this square. So basically the setup is we've got a circle. We're not really told much about the circle. We've got a square that's partly inside and partly outside the circle, but it kind of just touches on the edge. And, we've got the center of the circle. And that's it. So it was kind of, I mean, I was honest enough with the interviewer to kind of make it clear I was a bit rusty. So I think it might not have been a huge surprise to him that I struggled with this question. In hindsight, during the interview, I probably should have taken a bit more time to think about it, because what I ended up doing was kind of just jumping straight up to the whiteboard, drawing it up, and then trying to work it out at the same time as explaining it, which is probably just a rookie error. In the end, the interviewer had a bit of mercy on me, so once he could see that, I was not getting to the answer, he kind of prodded me a little bit and gave me a few little hints. So I got there in the end, but it was pretty clear that without that guidance I would not have got there. Interestingly, I still did get the job because I think the interviewer was more interested in my articulation and my ability to talk through things mathematically and kind of be clear and maybe simplify concepts as opposed to making them really complicated. So, good on him for that, for kind of seeing through whether I could answer this and seeing more about my ability to teach, because I think in the end, I stayed at that tutoring college it was really just one term. After the one term, I kind of decided that coaching college scene wasn't really my vibe. Yeah, I'm still trying to work out where I land on tutoring. I think tutoring is really great when you have a student who is genuinely struggling and just needs that bit of extra help for whatever reason to kind of fill in gaps that are there. But what I found at this college is that wasn't really the type of student being put in front of me. Often it was students who, for whatever reason, either the parents or the student themselves were trying to stay ahead. It was more of a mechanism to give advantage to certain people. And also, this is possibly a bit cynical, but at least at the college I was at, I also got the impression it was just a form of babysitting, where parents who had jobs that made them kind of work late needed a place for their children to be, and so that place, at least for an hour, was at this tutoring college. So in the end, I kind of got to the point where I thought there's probably better places I can be dedicating my time, and so most of my tutoring now is in a volunteering capacity where I can mainly focus on helping students who are at tutoring because they genuinely have a learning need, as opposed to trying to embed some kind of systemic advantage. So anyway, that's just a bit of background. But onto this question, I thought it would be a good one to kind of work through. So maybe what I'll do, I'll pause the video, give you a little chance to have a look and see how you might think about it, noting that it's only Pythagoras that you can rely on. And then after that short break, I'll come back and talk through how now, with the power of hindsight, I would have worked through this in the interview had I taken the time to really think about it. All right, so hopefully you're able to kind of get to a place where you could work this out. What I'll do now, I'll just show the way that I now would tackle this. It's probably not the only way. Often with math questions, there's various ways to think about it. But for me, I think the key is kind of, we're focused on the radius. And so we want to look at, I guess, points that are both on the circle and the square that represent the radius. And I think this point here is a good one. And so if we draw a line from the origin to this point, we can know that the length of that line is the radius. And I'll just call that r. And r is essentially what we're interested in, albeit in terms of h. Now the other thing I think we can do is draw a line from the origin just down to the square, noting that we'll hit the center of the square. And so we don't actually know what the height of this line is. I'll just call it x for now. But what we do know is that the length of this line here is going to be half of the width of the square, because it's a square, so 90 degrees. So we know that the width and the height are the same. They're both h. Because this line goes across the square, and we're kind of, if you kind of have a look at the way the square is constructed, half of it is on this side of the origin and half of it is on this side of the origin. We can say that if we're drawing a line vertically down from the origin to the square, then half of the square is on this side of the origin. So I think that's the setup. I think that's the key, or at least the key way to start. And then there's really just one other thing that we'll get to eventually that helps us kind of put this together. But I think noting that the interviewer gave the hint that Pythagoras' theorem is the key, it's probably a natural place to start. So what we can say is that r squared will be equal to the sum of the squares of the other two sides. So we'll have x squared plus h on 2 squared. And now really the question is, well, what's this x squared? And in particular, what's x in terms of h? Because we need to get that x in terms of h, and then we're kind of on our way. And this is where it can perhaps stump a lot of students. But I think the simplest way, at least that I can think about it, maybe I'll pick black here, is to go, well, if I go from the origin up to this point here, again, it's another one of those strategic points where it's both on the square and on the circle. It may not look like it perfectly, but that's the way the diagram is meant to be set up. I might have left a little gap there, but there's not meant to be a gap. It's basically touching the square and the circle. And so again, I know that this is R. And so if we look at this diagram, what we can see is that H, this whole height H, is equal to X plus R. Because if we start from this part of the circle, get to the origin, that's what we've defined as X. And then if we keep going another R, we've got the whole height of the square, and we know that's H. So if I rearrange, I can say that X is equal to, if I bring the R over, it'll be H minus R. And now that we've got X in terms of H, well, H and R, we can plug that in and then do some rearranging. So now I can, therefore, I can say that R squared is equal to H minus R squared, and then plus the H on 2 squared that we had before. And now we need to just clean this up a little bit and rearrange for R. So if I just think about this right-hand side, we'll do the first one squared minus twice the product plus the last one squared. And here if I expand this, we get H squared on 4. Now, interestingly, the R squared, there's an R squared on both the left-hand and right-hand side now, so we can actually cancel those. And what I might do is bring this 2HR over. So we'll get 2HR is equal to H squared plus H squared on 4, which really, if I put all of that over 4, it would be 4H squared on 4 plus H squared on 4. So we get 5H squared on 4. Now, I could then divide by 2H to get R by itself. So we'll get R is equal to 5H squared. And we're bringing the 2H down. And there's already a 4 there. So 4 times 2 is 8. So we're on 8H. And this H squared, the squared will cancel out with the H. So we'll get R is equal to 5H on 8.
Sonic boom!
And that's basically it. That's the radius of the circle in terms of H. So it's 5/8 of the height. That's the radius. And that's it. So, if I'd done it that clearly in the interview, I probably would have come off looking quite a lot better. But that's the beauty of math. I think often it's the case you don't get things right the first time, and it's really about whether you've got the perseverance to stick with it and eventually work it out, so that if you ever faced it again, you'd be able to do it. And I think that's perhaps what the person interviewing me saw, that even though I clearly wasn't getting it, I wasn't giving up, and I was staying positive, and at all times I was able to still articulate what I was thinking in a clear way, and I think that was the essence. But sometimes I think as a teacher or as a tutor or whatever context you're helping someone else learn, sometimes it can actually be an advantage if you also struggle through, because I think whoever is trying to learn from you, they can learn not only the mathematics, but they can also learn what it can look like to struggle with something intellectually but still not give up, and kind of learn that grit, I guess you could call it. Here maybe it's mathematical grit, the kind of habit of sticking with something even though the answer doesn't jump out to you right away. Because I think as math gets harder and harder, as you move through various topics, even if you find math pretty easy, say in year 7 or year 8, there is going to come a point where you hit some things that aren't obvious and aren't natural, and it's better to have developed some of those habits of really persevering through hard concepts, so that when you do finally hit some things that are difficult, you don't give up. So anyway, hopefully you found that question interesting, and you found the explanation helpful, and tick boom.